Welcome back. When the average person thinks of chemistry, they think of a scientist holding a separatory funnel, constantly shaking, venting, and waiting for layers to separate. It looks cool in movies, but let's be honest, in a modern mass spec lab, that funnel is the bottleneck of your clinical workflow. It's manual labor in a world of high-tech detection. Today, we are upgrading from the laboratory gym, LLE, to the precision factory, SLE. We are going to master the phases, so you can stop the manual chaos and start producing publication-ready data at scale. Think of traditional liquid-liquid extraction, LLE, as the laboratory gym. It involves manual, variable techniques that are difficult to standardize. An operator thinks they just need to shake harder to get more recovery. But a specialist knows that the partition coefficient, KD, is fixed by chemistry. Shaking is just a crude way to increase surface area, and it comes with a high cost of labor and time. We are moving toward a precision factory mindset, where the workflow is architected for robots and high-throughput mass spec. To master the selective filter, we need to master the liquid frontier. Our roadmap for this unit follows 4 strategic acts. First, we examine the legacy of LLE and the physics of the partition coefficient. Second, we introduce the SLE revolution, LLE without the shaking. Third, we scale up to 96 well plates for high-throughput MS. Finally, we provide a specialist's decision matrix on when to deploy which tool. This is how you upgrade a legacy process to a high-performance system. Here is the nightmare of the operator, the emulsion. You shake your sample, and instead of 2 clean layers, you get a cloudy mess that refuses to separate. A technician waits an hour for it to settle. A specialist knows that an emulsion is a data thief. It traps your analytes and ruins your reproducibility. I've spent thousands of hours shaking funnels so you don't have to, and I can tell you, manual LLE is where hand feel becomes a liability for standardization. What if we could get the power of LLE without the shaking? This is supported liquid extraction, SLE. Think of SLE as LLE on a solid-state drive. Instead of a funnel, we use a cartridge packed with diatomaceous earth, DE. We load our aqueous sample onto the bed. The water soaks into the pores and stays there, immobilized as a thin film. Then, we simply pour our organic solvent over it. Because the surface area is massive, the analytes partition into the organic phase instantly as it flows through. Diatomaceous earth is the magic ingredient. It's a natural microscopic sponge. As the aqueous sample soaks into this DE media, the nonpolar components concentrate at the surface. When the material is washed with organic solvent, the target molecules partition across effortlessly. This process speeds up the whole procedure and simplifies an otherwise time-consuming and highly manual task. You are using the architecture of the sorbent to drive the physics of the partition. The real genius of SLE isn't just that it's faster, it's that it's standardized. With no manual phase separation, we can put SLE into 96 well plates. Now, a robot can handle the extraction. In clinical toxicology or forensic labs, this is how we process hundreds of blood or urine samples a day with zero operator bias. You aren't an artisan shaking a jar anymore. You are a workflow architect managing a precision system. Let's look at the ROI comparison. LLE is manual and emulsion prone. SLE is automated and virtually eliminates emulsions. If you want high consistency and low % RSD in your mass spec data, SLE is the mandatory choice. An operator chooses LLE because that's how we've always done it. A specialist chooses SLE because they want to go home on time with data they actually trust. One pro tip: in SLE, pH is your volume knob. To get your analytes to leave the water and move into the organic solvent, they must be neutral. If your analyte is basic, raise the pH. If it's acidic, lower the pH. If the molecule is charged, it will stay stuck in the DE sponge forever. A specialist audits the pKa of their target before they ever load the plate. If you miss the pH, your recovery will be 0. Does LLE ever win? Yes. If you have a 1-liter environmental water sample, you can't fit that on a 96-well SLE plate. LLE is still the king of large volume extractions. But for small volume clinical samples like 200 microliters of plasma, SLE wins 10 out of 10 times. Rule of thumb: if it fits in a plate, automate it with SLE. If it's a bucket of pond water, stick with the separatory funnel. We've moved from the gym to the factory. You've learned that emulsions are data thieves, and that diatomaceous earth is the architect of the modern partition. Remember this mantra: standardization is the highest form of laboratory excellence. Don't leave your recovery to the strength of your arm. Leave it to the architecture of your workflow. This mindset determines your value as a generator of reliable data. You've mastered the phases. Your sample is pure, but even a pure sample can be too dilute to see. We have the needle, but it's still hidden in a chemical haystack. To find it, we need to turn up the gain. Join me in our next unit, Module 2 to 8, the signal booster, where we master concentration techniques to find those trace analytes. I'll see you in the next mission. Any questions on phase mastery?